everyone. Let's talk about we have part 3 multiple linear regression. Let me write. So multiple linear regression. For multiple linear regression, always remember that it is extension of simple linear regression. So multiple linear regression means nothing. There is a one continuous variable as earlier in a simple linear regression, and in simple linear regression there is only one independent variable. But here in multiple linear regression, one or more than maybe more than one multiple variables are there in this multiple linear regression. So you need to remember that. And we have certain condition. Let me write 1 dv I call continuous, and several iv I say. There is one continuous dependent variable with several independent variable. First assumption. Second assumption is we need to see the correlation between them. Between that correlation, remove correlation. I said remove VIF. Okay, VIF where VIF value comes VIF greater than 10. If VIF value is greater than 10, then remove VIF greater than 10 values, right? So you need to remove the value which are greater than VIF greater than 10. I mean to say you have several independent variable. I am talking about independent variable VIF value. You need to remove. Always remember that. Okay, independent variable VIF value you need to remove. You are comparing with dependent variable, right? So independent variable VIF value you need to remove it. So several independent variable are exist over there. So how will you remove that? If some one education variable has a 12 VIF and this level of learning has a 10 variable, like age is 22, means you have to go from highest. Okay, remove highest variable VIF first. Okay, always remember that you need to remove the highest value of that variable VIF. You need to remove. Likewise, you need to keep removing that. Then you ultimately there should not be no VIF exist at the end, so that you can fit this linear regression model, and that is okay, right? So there is one problem. You need to see for R square also. Remember, you need to see for R square also, and but VIF already VIF. You need to see for VIF also, right? So those are the major points you have to look at it in order to do some variables test in a test through this multiple linear regression. Okay, so let me go to the next one. So multiple linear regression. Multiple linear regression, and I did multiple linear regression. Y, sorry, here we call the Y, right? Capital Y, okay? Y with maybe you can call Y equals to alpha plus beta 1 x1 plus beta 2 x2 plus beta n x n plus u. Okay, so this is the part in a general model. Maybe there is a population kind of things we have to look at this formula. So this is Y intercept. This is Y intercept, right? So now you have beta 1, beta 2, beta n are slope of what? X1, X2 and Xn. X1, X2 and Xn. Okay, Xn. So you need to look for that. Okay, this is the y-intercept, and we can call beta 1, beta 2 is, those are the beta 1, beta 2, beta n is the slope of this one, x1, x2 and x3. So like this you have to consider it. Okay, so there is actual MLR estimation where we have a sample size, right? This is actually for ideal population, and this is just a formula, and we are using this one for linear regression estimation. So in estimation we use this formula, y hat equals to a plus beta 1 x1 plus beta 2 x2 plus beta n xn. Okay, we consider this like this. Okay, so this is the actual formula where we take this to estimate our equation. Okay, so here what you call a b1 b2 bn are least square. Okay, estimation of alpha. Okay, we earlier seen that alpha is y-intercept, that we call, right, alpha and beta 1, beta 2, beta n respectively. Okay, respectively. So we need to consider this one also in this sample kind of things, MLR estimation. Okay, for you always remember that there is a b1 b2 bn are the least square estimation of alpha. Okay, and b1 b2 b3 are also respectively, right? So what we do this equation, what we do with this equation means we'll do ordinary, there are some parameters, some we can write parameters may have unknown, right? So we use OLS, I call it as OLS, ordinary least square. So we use some of the parameters might be beta 2, beta n, and there is these things like alpha. Those parameters may have unknown, right? In that case we use overall this model we used for that ordinary least square, OLS ultimately, right? This is the final equations where in each programming they used in inner, but they are not showing that they develop their functions through these equations. Okay, so this is the main equations for multiple linear regression. Maybe I can repeat it again. Y hat a plus b1 x1 plus b2 x2 and then bn x1. Okay, for multiple linear regression. Thank you very much.